Welcome to your ultimate guide to supercharged classifier. So what is ExtraTrees Classifier? ExtraTrees, or extremely randomized trees, is a classification/regression model. So imagine a forest where every tree makes a decision and they will all vote for the final answer. That's how ExtraTrees works. It's an ensemble model, meaning it uses multiple decision trees to make predictions. By randomizing the way the trees think or is built, ExtraTrees reduces overfitting and increases accuracy. So how does ExtraTrees work? The focus of ExtraTrees primarily is on randomness. Features are selected, trees are split using random features to increase variety. For classification tasks, each tree in the forest votes on which class the input data belongs to. The class with the most votes is chosen as the final prediction. So when should you use ExtraTrees? ExtraTrees shines when you have large datasets with lots of features and you want a fast, easy to use model. If your data has some noise, like irrelevant features, and you want to reduce overfitting, ExtraTrees is your go-to. It's perfect for datasets that predict customer churn, for classifying images, or detecting fraud, or even diagnosing diseases from medical data, which is exactly what I did. I'll link my Github down below. Key hyperparameters of ExtraTrees that you should know. First, we have number of estimators, which is basically the number of trees. More trees usually mean more accuracy. Maximum features, consider the maximum number of features that are considered for each split. Maximum depth is how deep each tree can grow. Too deep and it might overfit. Minimum sample split is how many samples needed to split a node, and minimum samples leaf is minimum number of samples at the leaf node. But in a world where there are so many classifiers, why should you use ExtraTrees? You should use ExtraTrees because it handles large datasets effortlessly, it reduces overfitting thanks to its randomization, it's very easy to use with minimal tuning, and it gives you feature importance, which is great for feature selection. Now let's put that into practice. Here's a snippet of a sample code for ExtraTrees. Make sure to use Optuna if you want to make your code universal. It automatically searches for the best hyperparameters and gives them to you with no hassle on your end. Also, stratified k-fold cross-validation ensures your model's evaluations are stable and reliable, especially when dealing with imbalanced datasets. Once your model is trained, here's what to look at. Accuracy, recall, precision, and F1 macro. Accuracy tells you how often your model got things right. Recall is how many positives were actually correctly predicted, and precision is how many of the predicted positives were actually correct. F1 macro, on the other hand, is the average of all the F1 scores calculated for each class in a multi-class classification problem, treating all classes equally regardless of their size. But like every superhero, ExtraTrees has its weaknesses. It can be less interpretable when compared to single decision trees. It might have higher bias compared to other models, and it's not really ideal for small datasets if you have some noisy labels. Here are your key takeaways. ExtraTrees is a fast, stable model that can handle large datasets. Minimum tuning is needed to get great results. It reduces overfitting, gives you better, more reliable predictions, and it's perfect for tackling real-world problems like classification and regression. To wrap it up, you're now ready to conquer with ExtraTrees. Go ahead, experiment with it, fine-tune the parameters, and share your results. Happy coding!